All right, so let's talk about compound interest, and not only looking at it for compounding yearly or annually, but looking at what happens if we compound it monthly versus semi-annually. So your particular formula that you're going to use is similar to one we have been using, except we added a few things. First, I just changed y into a. All right, so that's your just final amount. P is now your new C, so it's your initial amount. R is still the same, the rate of change. T is time, but now we've added this N. And what happens is that we have to divide out the percent or the rate that you're going to use throughout each month, or however many times that you're going to actually be applying that to that amount. So let's look at some of these words that you need to know. So annually means just once. Semi-annually means 2 times per year. Quarterly, 4 times. Monthly, 12. And then weekly, 52. So these are the ones that you guys are going to have to recognize as you're going through and are reading these particular word problems. So let's look at this first one. It says, in 1628, Peter Minute, a governor of a colony of New Netherland, bought the island of Manhattan from the Native Americans for beads, cloth, and trinkets worth 60 Dutch gliders, $24. If the money the Native Americans received had been invested at 6% per year compounded semi-annually, how much money would there have been in 2026, or will there be in 2026? So first we're just going to, I always start off with this particular formula, which we should train ourselves to start using this one. So we're going to take and look at all of the information that they have given us. So first, we know what the principal is, the starting amount. That's our $24. Your rate is 6%. So remember, we have to take our 6%, make it into a decimal. So we have 0.06. We're now dividing that number by the number of times that we're compounding. So we're compounding semi-annually, so that means twice. And then when we look at the exponent, we now have time. So we have to figure out how many years have passed. So you have 2026 minus 1626. And that's going to give us 400 years. And then we also have to multiply that by 2. So that way we end up compounding it that many times. Okay, so I'm just going to simplify this kind of fraction up. This is what I would do along the way. So here inside the parentheses, it's going to end up being 1.03. How I got that is I took this, basically the 6 cents, divided it by 2. So just do 0.06 divided by 2. Add 1, you get 1.03. Then we've got 400 times 2, which is 800. Now it just looks exactly like what we've been doing. So you're going to go through, you do 1.03 raised to the 800th power, multiply that by 24, and you should end up getting the following answer. And make sure that you stop and actually try this to make sure that you're agreeing with me. So in the end, if they invested that $24, they would have had at this point $3,274,169.24. All right, so let's flip over to the other side and look at those two examples. All right, so again, we're going through and we're just going to read the problem. You borrowed $15,000 for 5 years at 3.25%, and the interest rate is compounded quarterly. What is the total that you will pay back? So we're going to take our formula, plug in our information, and go from there. So principal starting amount is $15,000. Your rate, you're going to take your 3.25%, make it into a decimal. We have to divide that by the number of times we're compounding. So we compounded quarterly, so we divide that by 4. Your exponent is going to be the number of times you're compounding, which is 4, times the number of years, which is 5. So I'm going to rewrite this problem so that way you can see what you would plug into your calculator. So inside here, once we divide this by 4 and add it to 1, we get 1.008125. We're going to raise that to the 20th power. Next step is that we're going to, again, take that 1.008125, raise it to the 20th power, get that answer, multiply it by 15,000. So in the end, you get $17,635.14. Okay, next problem. So here you've got another investment. You're investing your allowance of $525, which gets 10%, it's a 10% rate applied, compounded monthly for 2 years. How much will you have in 2 years? So again, start with your formula. Okay. Principal is $525. Your rate is going to be 0.110 because I'm taking 10% again, moving the decimal place over, get 0.10. If I'm compounding monthly, I'm dividing that 10 by 12, and then we do 12 times the 2 years. So again, I'm going to rewrite this problem so that way you can see what you would plug in. When you take and you divide 0.10 by 12 and add it to 1, you should end up getting 1.0083, and then it'll be raised to the 24th power. We're going to go through, enter everything into your calculator, and you will end up getting $640.71. Making sure that if you're dealing with money that you're going to round to 2 decimal places. So these are the notes for this section. What I'm going to do is look at just setting up the first page of the practice quiz net. So if you look on your Day 66 packet, you should see this. Your quiz next week will look similar to this, where I'm going to give you a problem. You have the question to apply to. So here, the first one, again, you're just doing a simple, you're just compounding annually, so you don't have to worry about dividing by n. So you'll have your starting amount, which is 500. You'll do 1 plus the rate. You got to make sure we change that 5% into a decimal. So it'll be 0.05. And then the number of years is compound is 5. So then from there you can take it and solve that problem. When you look at the second one, we're doing a decrease now. So the one thing we always have to watch out for is that we aren't adding in the parentheses anymore, we're subtracting. So again, you start off with the amount that you have. The computer decreased by 50%, so we're doing 1 minus 0.50. Okay. And then we want to see how much it's worth in 5 years. So when you go through and you simplify, make sure that you're subtracting now in between. So you'll have 0.50 to the 5th power. So when you enter that in, you're going to see that you'll end up getting a much smaller number here when you're multiplying by 1100, because you want to see your answer should be less than 1100. Last one, just like we were just talking about, we're plugging everything into the new formula that we've been talking about. So you're going to have your A equals 200, and then you do 1 plus, you've got your rate here of 6.25%. So we do 0.0625. You have to divide it by the times that we're going to compound it, which is 4. And then when we go in and start multiplying, we have to do 6, the number of years, times the number of times we're compounding. So this is where you have to use, just kind of go through, simplify each part, make sure you're watching your signs and your dividing rate. So we'll look at those answers when I come back next week. And then the next page, you're really just using your notes, fill in this table here. And then the rest of the problems are just, you have to watch out what you're going through and solving. So for example, if we look at number 1, it says you've invested $52,400 at 6% compounded annually. So again, you're not going to have to divide anything for 5 years. What is your total return on the investment? So when you go through and set this one up, you can use this formula at the top, but you don't have to divide by n or multiply t by n. So you end up with something that's similar to the first formula that I showed you. So we take this, we do 1 plus or 6% as a decimal, and then raised to the 5th power. So once you enter all this in, you should end up getting $70,123.02. Okay, you can double check my work and make sure that I've set that up right. When you get into questions like number 2, it says you've borrowed $10,400 for 4 years at 12.7%. And the interest is compounded semi-annually. So then that's when you know that you have to divide by n or multiply by n with the exponent. So this one I'll set up for you. You've got 10,400. And then in parentheses, you're going to have 1 plus 0.127 divided by 2. And then 4 times 2. So then when you go through, enter everything in, you'd have 10,400. And then in parentheses, it'll end up being 1.0635 to the 8th power. And then you can go through and figure out how much you'd have to pay back. So try the rest of these problems. We'll look at them next week, and we'll go from there.